Hey guys, what we're going to do today is learn how to multiply mixed numbers by whole numbers. We did talk about this last week, but I want to make sure that you guys feel fluent with it. We haven't talked about it in a while. You're going to learn this in two ways, using the distributive property and converting the mixed number in the problem to a fraction, an improper one, and then treating the problem like a fraction times whole number problem. But in order to be able to do this, you need to be fluent with these three things: the distributive property, converting mixed numbers to improper fractions, and cross-simplifying. So let's chat about the distributive property first. This is something that you guys have seen a lot in hands-on equations, so it should sound very familiar. If you see a problem that looks like this, where you have a number times the sum of two numbers, okay, it needs to be a sum or a difference, but we don't really go into that quite yet. You guys know that you can do 5 plus 3 is 8, and you can multiply that by 2. That's one way to do this, right? To do the addition in the parentheses first and then the multiplication. But the distributive property says that you can create two multiplication problems from this by distributing the 2 to both numbers in the sum. So 2 times 5 can be done, which would then be added to 2 times 3. Okay, so the answer would be the product of 2 and 5, which is 10, and 2 times 3, which is 6, or 16. You get the same answer. But it basically means that you can distribute the number on the outside of the parentheses and multiply it by both numbers inside the parentheses and find that sum. Okay, so that you need to know to be able to do mixed number times whole number multiplication. The next thing that you guys need to know is how to convert a mixed number to an improper fraction, okay? The denominator indicates how many slices are in one of the wholes, and the whole number indicates how many wholes you have. So this, when you do this multiplication problem, okay, this multiplication problem gives you the number of pieces inside 4 holes. Okay, 7 pieces in each hole, and there's 4 holes. You'll have a total of 28 pieces inside those 4 holes. Now this number gives you the amount of pieces that remain after the 4 holes. So this needs to be added on. Okay, so you're going to do 4 times 7 and add on the extra pieces, and then this is the amount of 7s you have. Okay. So what you're doing is you're just kind of going in this circle, multiplying first to see how many pieces you have in 4 holes, and then adding on the extra holes. So what you have here is 28 plus 4, 32 sevenths. Now it's a fraction that you can treat like a fraction, just as we would do in a fraction times whole number problem. The other thing that you need to be really good at is cross-simplifying. So what I'm going to have you guys do really quick is apply this. Oops, I should get rid of this first. This is a whole number times fraction problem. It should look familiar. 6 times 4 36. Now if you notice, if you add this over 1, 6 ones, you can cross simplify this way by dividing by 6, dividing by 6. And you have a much easier problem here. You have 4/6, right? Or 2/3. Okay, so you need to be able to recognize, hey, in this whole number times fraction problem, just like, I don't know, let's see, this one, if you were to give this a denominator 7 ones, you would notice that you can cross-simplify 7 and 49. Divide by 7 is 1, divide by 7 is 7. And again, you have a really easy problem. A 1 by 4, which is a 4, and a 1 by 7, which is 7. So you can apply cross-simplifying to doing fraction times whole number problems. All right, let's first discuss how to use the distributive property. And we're going to use this example right here. Now, a while back when we first started talking about mixed numbers, you guys told me that 6 1/2 is equivalent to 6 plus 1/2, because you're just combining 6 wholes with 1/2. And we know that addition is kind of the act of combining. So really, the equation or the expression I just wrote in purple is the same exact thing as the one that's in red. Okay, because 6½ is the same thing as 6 plus 1/2, right? With the distributive property, which I'm going to write it as right now, the number that you would distribute to both numbers inside the parentheses would be 5. So you'd be doing 2 multiplication problems here. The product of 5 times 6 and the product of 5 times 1/2. Okay, so 5 times 6 is 30, right? And 5 times 1/2 is 5/2. Now you guys know we need to make this into a proper fraction, right? It goes in 2 times with 1 left over. And now we have a very easy problem. 30 plus 2½ is 32½. Okay, so really it's 2 sums that you're adding together. This, the product of 5 times 6 is 30, and the product of 5 times 1/2 is 5/2, and then you add them together just as we did down here. Okay, let's do one more example of that. And you can choose which one, or actually I want you to write that one down in your notes, but this is just one more for extra help. So let's do 7½ times 4. Okay. Remember that 7½ is the sum of 7 wholes and 1/2. And we're going to multiply that sum by 4. Okay. Now I'm going to rewrite this so that I can recognize it as using the distributive property with the 4 on the outside of this sum. Now the 2 multiplication problems I have when I distribute the 4 are 4 times 7 and 4 times 1/2. Okay, 4 times 7 is 28, and 4 times 1/2, if we just take this and move it right on over, is 2. So your answer is 30. Now I hope that you see this with the picture too. So I want to show you the picture just very quickly to get your brain remembering why. Why can we take 4 groups of 7 and 4 groups of 1/2? So if we were to draw 4 groups of 7½, it would look like this. So here's, I'm going to draw my holes first. Oops, I drew one too many. Okay. So I'm going to give this the value of 7, this value of 7, this value of 7, this value of 7. And I'm going to add on an extra 1/2. The proportions are not very good, but that's okay. Now what you can see here is 4 separate groups of 1/2. Here's 7½, sorry. Here's the first group of 7½, 2 groups of 7½, 3 groups of 7½, and 4 groups of 7½. Now I hope what you can see is that there are 2 multiplication problems here. You have 4 groups of 7, and you have 4 groups of 1/2, which is just what we did down here. 4 groups of 7 would give us 28, and 4 groups of 1/2 gave us 2. And then when we add those together, right, we get 30. So I hope you see this with the picture as well. Okay. Picture is very important. Another way some people like to show this with the picture, 7½ times 4, is kind of what we did in the past, like this, where this would be 7, this would be 1/2, and this would be 4. So we have this area right here would be a 4 by 7, right? A 4 by 7 is 28. And this area right here would be a 4 by 1/2. So that shows 2 separate problems happening here, right? It shows 4 groups of 7 and 4 groups of 1/2. So that's another way to represent that. The next way I want to show you is using just converting to a fraction, simplifying, and then multiplying. So let's do that same problem, 5 times 6½. Okay. Now, what you need to do is take the mixed number and make it into an improper fraction so that you can apply the familiar fraction times whole number multiplication to the unfamiliar, which is mixed number times whole number multiplication. So just like we practiced, the equivalent improper fraction is 13 halves. 6 times 2 is 12 plus 1, 13 halves. And now you're able to just multiply like normal. Now we are not able to simplify this problem. Let me just check this out. If I just make this 5 ones and I look across here, I'm not able to cross simplify. If I look across here, I am not able to cross simplify. So I'm going to have to go ahead and do 13 times 5. 65 halves. And this would be a case where I would say long division is your best option for making this into a mixed number again. So 2 goes into 5 twice. So you have 32 and a half. Okay. Let's do one more of those. This time we're going to make it so it can be cross-simplified. Let's see, 4 groups of 3 and a fourth. Okay. So in this strategy, this method is to convert the mixed number into an improper fraction, okay, which would be 4 times 3 is 12 plus 1, 13 fourths, correct? Now we're going to bring down the times 4 and see, can I cross simplify here? Yes, I can. I can cross simplify, and my greatest common factor would be 4. 4 divided by 4 is 1. 4 divided by 4 is 1. And so now it's a 1 by 13 and a 1 by 1. So it's just 13. Now you guys know that we've talked a lot about this before. Being able to just take this mentally, the divided by 4, and move it over here, correct? Because we know that multiplication is commutative. And that kind of goes along. This is why we're able to cross simplify. Some of you might notice, hey, that's 1, so my answer is 13. Okay. But I want you to start thinking about when you see these types of problems, right? 16 times maybe 3 fourths. You can start to look and cross simplify just as you would in a fraction times fraction problem. Okay. So look out for that after you convert mixed numbers to improper fractions. 2 times 3 is 6 plus 1 is 7 times 4. I hope you guys see that you're able to cross simplify here. Your greatest common factor between 4 and 2 is 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And so, just add this on to make it clear, a 7 by 2 is 14 and a 1 by 1 is 1. So your answer is 14. So those are the 2 strategies that I need you to know. And it really doesn't matter to me which one you prefer to use. Okay, one might be the best strategy over the other depending on the problem, but I need you to know both. Okay, so go ahead and take this time to practice number 1, 2, 3, and 4 below. I want half of them practiced with the distributive property and half practiced by converting the mixed numbers in the problem to fractions, simplifying, and then multiplying.